All right, let's get this video started here with worksheet number 8. This is page 2. Okay, so remember that order matters for permutation and does not matter for combination. Okay? And so let's see if I can write over here. So the formula for this, whoops, let me go back, give me some more room. R and R. So n factorial, and then you're going to subtract the 2. Like I said, this is not necessary to do, but that's what the formula says to do. I mean, mathematically, it has to look like that, but using common sense, you don't have to do. You just have to use the first 2 or 3, whatever the R is. Okay. Versus combinations. Combinations is going to be almost the same thing, except with that extra piece in there. It's the R, and that's going to do away with the duplicates. Okay, it's going to do away with the duplicates. Okay, so we're going to do the odds together, and then you and your partner are going to work on the evens. Okay, so number 9 we discussed last time, right? So here, order mattered. So if you say yes, then you want to do, it basically looks like that, but this is basically 3 factorial, okay? Okay, so 6 different ways. So if I do the sample space, you're going to see 6 different ways that we can arrange this. Okay? So let me do that real fast on the board. So let's take a look at number 11. Okay, so we mentioned that sitting in a plane, the order doesn't really matter. Okay? So you have 9 passengers, okay? Only 5 seats are available. So order matters, yes. Order does not matter, sorry. So it's a combination. Okay. So to look at the formula exactly the way it's shown, then it's going to be 9 factorial is using all of them, but we're not going to use all of them. We're only going to use 5 of them. I'm sorry, we're going to use the first 5. So you have to take away the last 4 of those. This is why there's a subtraction here. And then there are duplicates involved. So again, I recommend using 5 of the 9 factorial. So 1, 2, 3, 4, 5, the first 5 numbers. If you're doing this by hand, by the way. Okay, if you're not using your calculator. So only using the first 5, that's the job of the 9 minus 5, which is 4. And then the 4 is taken away. The 4 that we don't need is gone. Okay, so we didn't need that formula to tell us that. We just needed the 5 to tell us to use the first 5. Then we can do 5 factorials left here. Okay. So you can type this, you can type all the top in your calculator and then type the bottom in your calculator, or you can start reducing, make the number smaller if you want. Okay. Okay, questions on 11. You could also just type in your calculator. You're going to have to use parentheses though. In your calculator, you could do 9 factorial divided by parentheses 4. 9 minus 5 is 4 factorial times 5 factorial. Put another parentheses there, and that'll take you straight to the answer. Okay, if you want to do it that way. But you have to put parentheses. If not, it's not going to divide by 5 factorial. It's going to multiply it. So it's going to be different. Okay. Okay, what about 13? Entering a race, there can be no ties. How can the race finish? Does order matter? Yes. Okay. So it's a permutation. Now, if you're going to use all of them, if you're going to use all the 6s, that's what the 6 per P6 is saying. If you're going to use all of them, then it's basically just 6 factorial. Okay? Remember, the number on the right tells you how many you're going to use. And if you're going to use all of them, then that's the definition of factorial. Just use the 6 factorial button on your calculator, or go ahead and just type this in your calculator if you don't have that. And don't worry about the 1 either, right? Okay. Okay, what about a baseball manager who wants to arrange 9 starting players in a batting order? Someone bats first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. Does order matter there? Yes. So again, we're using up the whole 9, so we don't need to do the formula. We just need to do the whole 9. We're not going to divide anything out. We need all the 9s, all the numbers for the 9 factorial. Okay, so that's basically find the exclamation mark in your calculator and hit enter. Okay. And I think we have one more, I believe. So a swim meet has 12 participants for the 50-meter swim. The 3 fastest speeds will receive medals. Order definitely matters there because I want my gold. or silver or bronze? How many ways can the medals be awarded? So order matters is a permutation. So remember, if you focus on what you need, then the 3 is saying I need 3 of the first 12. Okay. I mean of the number 12. So 12, 11, 10. One, two, three. I think the formula can get kind of cumbersome and confusing, so okay, so what I want you guys to do in your grab a partner, okay, and one paper for 2 people. So worksheet number 10 is next. This goes more specific, guys, to your assignment, like I said. Okay, the word problems, you got the initial introduction with the formulas, and then on the third assignment, you will be deciding, and towards the end of each assignment, there's some word problems, but we wanted to go ahead and introduce it to you first, and then keep at it throughout our discussions and studies. Okay, so 11.7 and 8, worksheet number 10. So this is going to take us back to our initial discussion that we had about the ATM code. Okay, I just gave you an example of 4 digits, and they're just numbers. So now this is a little bit more advanced. This is 2. The first 2 have to be lowercase letters, and then 4 digits. So it's 6 total. Okay, so determine how many different passwords are possible if repetition of letter and digits is permitted. This is the one that has no restrictions, okay? So let's lay this out. So you have the first 2 are letters. You can pick any letter from A to Z. Okay, and then the last 4 are digits, numbers. So basically we're doing 0 through 9 in each case. So you're thinking to yourself, how many possible options are to choose from in the first part of the password? How many letters? 26. Because you can repeat the same letter if you wanted to, like AA, then that means we still have 26. If it said no repetition, then you would have to bring it down 1. Okay, so this is, again, all 26 letters. How many digits? 10 digits, and we can repeat it if we wanted to. So we could have AA time and 1111 if we wanted to. Okay. So in your calculator, you have to multiply all those numbers, which I'll save you the time. It's 6,760,000. Okay. Now, what if there's some restrictions put in place? For example, like letter B says, repetition of letters and digits is not permitted. Okay, so let's get the same scenario. Now, in the first choice of your letters, how many options do we have? All 26. Once you use up one, you cannot use that same letter. So you have to only choose from 25. Okay, so the number goes down. For the digits, the first digit, we have all 10 of them. But once you choose one, you only have 9. If you choose again, you just chose 2 of them. So now you're left with 8 and then 7. Okay, so remember what's going on here. We're, depending on the context, our numbers can change. Okay? So 26 times 25 times 10 times 9 times 8 times 7 is 3,276,000. So remember from our discussion from last time, if you put restrictions, it's going to cut your options in, well, at least the other one was in half. This looks about in half as well. Okay? Yeah, about 3 million less. So that's not good for you as a consumer, but it is good news for a hacker or a thief. Okay? All right. Once again, we have our 6-item password here. So here's the restriction. The first letter must be a vowel, and the first digit cannot be a 0. And repetition of letters and digits is not permitted. All right, a lot of restrictions there. So let's take it one step at a time. In our first spot, we are going to choose out of 5 vowels, right? So that's how many you have to choose from in the first spot. 5 vowels. Check. So I can't repeat that vowel in my next line. So out of 26 letters, I only have one. I have one less. 25. Okay. Okay. Next, we can't choose all 10 digits because there's a restriction. On the first digit cannot be a 0. So how many options do we have? 9. Can't choose 0. You can choose 1 through 9. In the second digit, I can choose 0 now. There's no restriction on that second digit, but we already picked the number. Okay? The other restriction is you cannot repeat the number you just chose. So how many digits do we have to choose from in the next one? 9 again, right. Okay? All right, that pretty much takes care of the restrictions, except on the next 2 digits, we have less and less, so 8 and then 7. So now you got to multiply all those numbers together. So with even more restrictions, a lot more, then we have only about 500,000 options to choose from. Super good news for a hacker. Okay? So what is this trying to tell you guys? You want no restrictions. If this is your password to something very important, you want long as possible with a combination of letters, numbers, and a symbol, or they call it a special character. Okay? You put more stuff in there, it's going to make your options like a lot. Okay? Yes. You gotta wait till I'm finished talking. So, yeah.
Are we allowed to repeat digits since the 9 is repeated? Or
No, you can't. You can't repeat the digits. No.
so why is the 9?
That's not a digit. Those are how many options that we have to choose from. Those are total numbers that we can choose from. There's 9 for the first one, 9 for the second. Okay, so let's continue on the next question. Okay, so now we're at Best Buy. They have just received a supply of Apple iPads. The iPads come in the following colors: tangerine, strawberry, blueberry, grape, and lime. Sadie Bragg, the floor manager, decided to display one of each color iPad. In how many different ways can she display the 5 different color iPads on a shelf? Okay. Decisions. Okay. Does order matter here? Yes. Okay. Because once she chooses tangerine to go first, well, she can't choose tangerine to go somewhere else. That's her spot for that. So order matters. Every single arrangement that she chooses is a completely different arrangement. They're not the same. And she's using all of them. Whoops, sorry. So order matters. So that means we're going to it's a permutation of 5 colors, but we're using all 5. So we don't have to use that big formula, guys, because we're using all the options. So that means, so whenever you get a repeated number for permutation, just do 5. Just do that number factorial, okay? And that gives us how many? 120, okay? All right. Letter B. If she wants to place the strawberry iPad in the middle, how many different ways can she arrange the iPad? All right. So if you think about the 5 orders, let's go back and say, okay, there's our 5. So in the first spot for the iPad, she had 5 colors to choose from. Once she put a color there, the next spot she had 4 colors to choose from, and then 3, then 2, and then the last one, you had no other place to put it than that spot. So that's the 1. So now she's getting very particular. She wants that for some reason in the middle, or maybe her boss wants it that way, okay? So 1, 2, 3, 4, 5. So guys, for the middle iPad, how many options does she have for the middle iPad? Yeah, she's already made that determination that it's going to be strawberry. So that's 1 option in the middle. Has to be that 1 color. Cannot be any other color. Okay? So, once she goes to the front of the beginning, she's going to say, well, I already put the strawberry in the middle, so how many options do I have in the first spot? 4. Then she has 3. And then here she has 2. And then over here on the far right, she only has 1 again. Okay, so just with that 1 restriction, her options went from 120 different arrangements to 24 arrangements. Okay? Now, letter C. So here, strawberry. Oop. That's strawberry. Has to be strawberry. And then you can put anything else wherever you want. So now it's even more particular. She wants the blueberry iPad to be the first and the strawberry iPad to be the last. Wait. Okay, so she wants the blueberry first and the strawberry last. Okay, that means she has made her determination. There's only one option you can put in each of those. So one here and one here. Okay, so the blueberry goes first, strawberry goes last. So she's used up 2 of her 5, so that means she only has 3 left. Right there she can choose from. In the middle she can choose from 2, and then over here she can only choose 1. Whatever's last.
6.
Very good. Okay. So this is a little game of restrictions. Now, let's go to 3 and 4. Questions on number 2.
Okay, so the strawberry iPad and the blueberry iPad are both 1. Because you could only use them 1.
Right. Mm-hmm. Now, it's different if you had 2 blueberry iPads. Then that's different. But she only has 1 of each to put on display. Okay. Okay. So number 3, in how many different ways can 7 different cars be parked in a straight line? You're using all 7, guys. So this is just a plain old 7 factorial. Okay, where does that come from? It comes from this right there. But it's better just to use that one. So notice the difference between if order matters and you use all of them, well, it's just that number factorial. But if you use a few of them or some of them out of all of them, then it's important to do the formula. So here we have 5 letters. You're going to choose them 3 ways. Repetition is not allowed, so okay, so if you don't use all 7, then it's only going to use the first 3. So 7, 6. Wait. Sorry, where did I get 7 from? 5, 3. So use the first 3 of the 5. 1, 2, 3. There you go. So 20 times 3 is 60. Okay. All right. I want to talk about running out of time here. So let's talk about 7 and 8 right here. Okay, so quick discussion on letters, all right? So let's say we had, the word car. It has 3 letters, C-A-R. Notice that they are distinct. They're not the same letters. So how many ways could we order this? 6. Comes from 3 factorial. Now, let's see the sample space real fast, okay? Sort of like what we did on the board earlier. So we have CAR, and I can switch the A and the R, keep the C first, just to keep track. Then I could put the A first, put CR, and then switch the C and the R. I could put the R first, CA, and then AC. Those are the 6 for the sample space. Okay? And the reason why we have all 6 is because all the letters are different. Okay? Now, what if I have the word Bob?
6.
Be careful.
4.
So, okay, let's do the 6 that we're thinking of, right? That you just thought of. I can switch the O and the B and do that, right? All right, now I'm going to put the O first. And I'm going to switch those 2 B's. Right? Is that a different arrangement?
No.
So there's duplicates here, okay? What if I put the last B first? Well,
No.
that's the same thing as the first one. Okay? All right. So if you look, guys, we only have Bob. We have BBO and OBB. That's it, 3. Because this other one's the same as that. That's a duplicate. This one is the same as that one. And that one's the same as that one. So what this is trying to tell you is that if you have repeating letters, those are duplicates. So how do we get 3 mathematically? We have to do this. Yes, we have to do 3 factorial because there's 3 letters for Bob, but since B appears twice, there's 2 B's, I have to put 2 factorial there. So there's your 3 right there. All right. So let's take a look at Mississippi. You got to find all the duplicates first. All right. Anybody from Mississippi? I wish. All right. Can you spell it though without looking? All right. Yeah, what she said. Right. All right. So, how many I's?
4.
4 I's. How many S's?
4.
Anything else repeating? All right, so that's going to create duplicates. That means we need to divide it out. So, how many letters total for Mississippi?
11.
All right, so that means we need to do 11 factorial. That's if all the letters were different, we would leave it like that. But they're not different. There's duplicates. So, we got to do the 4 I's, the 4 S's, and the 2 P's. M is only once. I'm only doing repeats in the bottom. Okay? So those are my I's, those are my S's, and those are my P's. Okay? So again, you could type this in your calculator. As long as you put parentheses over the bottom, you could type it all in and just hit enter. If not, you're going to have this big old mess of numbers. You got to start keeping track. So in the end, you get 34,650. Okay? Okay. So let's see here. Let's do one more. So Cincinnati, how many C's are there? 2 C's. We have a bunch of I's. How many I's? 3. How many N's? 3 N's in Cincinnati. And what about T's? 2. Okay, so all those numbers have to be factorial under the 11. There's also 11 here, okay? So 11 factorial divided by all my repeats. Okay? Type all this stuff in your calculator, or you break it out and work it out that way. What is it going to give you? Okay. Is it?
Yeah.
Okay. Sounds good. Okay, so real quick before you go, let's pick a few of these where it says classroom practice. So let's turn in number 10. 12 and 14 right there.
Is that homework?
No, that's real quick with your partner.